This is a video on the Week 1 Operators Worksheet. The Operators Worksheet deals with a couple of symbols that are used in Java. And the first thing that you see is a table with a number, a percent sign, followed by a 4. It's an expression. Expressions evaluate to something, and that means it's the answer to the expression. 1 plus 2 is an expression. It evaluates to 3. In the same way, this 9% 4 evaluates to an answer. The answer given here is 1. Now, if you notice in the right column, it's in a circular sequence. It goes from 1 to 2 to 3 to 0, and then it repeats 1 to 2 to 3 to 0. On the far left, the left number is sequential. 9, 10, 11, 12, so on. It increases. So it would be logical to assume that if we continued this table, going to 18, 19, 20, and so forth, that this cycle on the right would also continue. 1, 2, 3, 0, which it does. What this table means is that this integer, which is a number without anything to the right of the decimal, is divided by this other integer, nothing to the right of the decimal, and whatever the remainder is in this third column. 9 divided by 4 is 2, remainder 1. 10 divided by 4 is 2, remainder 2. 11 divided by 4 is 2, remainder 3. And 12 divided by 4 is exactly 3, so the remainder is 0. And then it repeats. So as we look at these questions, the numbers that evaluate to 4 evaluate to 0, percent 4 evaluate to 0, are numbers that divide evenly by 4, 12, and 16. 12 goes into 4 exactly 3 times, 4 goes into 16 exactly 4 times. So every time you encounter a number that is evenly divisible by 4, you would not have a remainder, so that third column would be 0. If you have a number evenly divisible by 5, it would have a remainder of 0, such as 10, 15, 20, 100, or 1,000. If the remainder is 1, in the table we have a 9, a 13, and a 17. All three of these numbers are 1 more than a number that is evenly divisible by 4. So I will leave this number 4 to you, given that explanation. Please keep in mind that the second number on these last two is a 5 and a 6. It's not a 4. What we're coming up with on number 4 are the remainders. Number 5 says, consider how you were taught to do long division in elementary school. Finish solving 79 divided by 5. What is the answer? Well, 5 goes into 7 once, so there's the 5. It leaves a remainder 2. Bring the 9 down. 5 goes into 29 5 times, so there would be a 5 right here. I don't know if I can put a 5 in there or not. I don't think I can. It's a picture. but that's a 5, and it leaves a remainder of 4. So it's 15 remainder 4. I will leave you to this number 6, the reading question, and that will conclude Model 1. In Model 2, you have this scenario, 9 divided by 4. Oh, this is divided by. We don't have a percent anymore. The slash indicates its division. Please notice that all of the numbers on the left are integers, meaning there's nothing to the right of the decimal. In our computer programming language, that means the answer cannot have anything to the right of the decimal. And when the division occurs, whatever's to the right of the decimal gets dropped off. 9 divided by 4 is 2 with a remainder of 1, but we don't care. We drop it. So it's just 2. The same with 10 and 11. When we get to 12, 12 divided by 4 is 3 with no remainder. 13 divided by 4 is 3 with a little bit extra, which we get rid of. 14 divided by 4 is 3. We get rid of the extra. 15 divided by 4 is 3. We get rid of the extra. 16 divided by 4 is exactly 4. And 17 divided by 4 is 4 with a little extra. The reason we get rid of the extra in the answer is because all of the numbers in the expression are integers. That's important. Let me say that again. The reason that we drop any values to the right of the decimal in the answer is because all of the values in the expression are integers. Nothing to the right of the decimal over here. So in number 9, 9 divided by 9% 4 is 2, and with a remainder of 1. The answer to this is the remainder. 9 divided by 4 here is the integer part of the answer, a 2, ignoring the remainder. In Model 3, you have expressions. These are expressions over here on the left. And they have at least one decimal point in each expression. Because they have at least one decimal point in the expression, we use the part to the right of the decimal in the answer. If it has a decimal point anywhere in the expression, then we include in the answer the part that's to the right of the decimal. 9 divided by 4 is 2.25 because of these decimal points. Now on this third one, there's only one decimal point, but since there's at least one, it still holds. 11 divided by 4 is 2.75. We include that. Even when we have a whole number answer, because that decimal point is beside the 12, we say the answer is 3.0, not just 3. Now on this rounding, if the part to the right of the decimal is less than 0.5, you round down. In other words, you get rid of the number to the right of the decimal. That's why this is 2. If the number to the right of the decimal is 0.5 or more, you round up. All of the answers in this last column will be integers. So on number 12, It wants you to compare 9.0 divided by 4.0 compared to 9 divided by 4. How did the evaluates 2 answers differ? Well, the first one will be an exact answer, 2.25. This one, because it only contains integers, will just be 2. Now in 14, the first 3 examples in this table have a decimal point. So the evaluates 2 answer over here will be an exact amount. The last one, though, only has integers. So it will only be the integer value. Here's a hint, it's 3, without anything to the right of the decimal. When a number has the decimal point, it's referred to as a floating point number, as opposed to numbers that do not have a decimal point, and they're indicated as integers. These are the 2 groups, integers and floating point. Operands are the numbers in the expression. So the operands in this last line of the table in 14, the operands are 14 and 4. That's what an operand is. And then I'll leave 17 and 18 for you to think about. And that concludes the help on the first worksheet on operators.